Well, good afternoon, everybody, and welcome to the redo of Monday's session. So again, I apologize for what happened on Monday, but we're going to straighten it out this time. And so we're not going to do any poll questions today, none of that. So just to recap, what we're going to go over is just the very basics of configuration for the consolidator. What I mean is setting up inputs and channels. This is going to be very basic, but a good understanding of these basics is really going to help us out in future classes where we start combining these types of objects. So specifically what we're going to look over today is we're going to look up how to set up an input. That's like a 4 to 20, a physical process input. We're going to learn how to turn that input into a channel. And then we're going to learn how to create a screen and then add those channels. And then lastly, we're going to look at how to set up an output and then tie that to a channel that we've created. So without further ado, I am going to share my screen, but what I would need from everybody is in 2 seconds, let me know if you don't see it. So you should be able to see my desktop. So if somebody could go ahead and either say yes or no, I can see it, that will let me know that I can continue on. Okay, perfect. So we can see it. Awesome. So this is what the ConsoliDator Plus configuration software looks like. What you see on the screen is what actually I was actually making up a study guide for our last class, and this is the configuration file I'm working off. So the very first thing we want to do when we configure this device is we need to tell the software which inputs and outputs our device has. So here's what I mean. So we come up to this file button here, we press new, and then we have slots 1 through 7. So this is a demo that I'm connecting this to, so I just know off the top of my head which inputs I have. So for example, in slot 1, I have pulse inputs. In slot 2, I have milliamp inputs, and then I skip a slot, and I have milliamp outputs. I skip a slot, and I have relay outputs. Now, this might be different. If you have a consolidator that has nothing but 28 analog inputs, all 7 of those slots are going to have milliamp inputs. So it's very dependent on the device to which it's connected. So once I have that done, I click OK. And now this is a raw software. So there's nothing on it. This is just plain. So the first thing we want to do is set up an input. And so what we do is anytime we want to set something up, set up some new object or look for something new to create, we're going to pick out of this pool of objects here. So this is the left side of the screen is where we're going to grab everything. So I'm going to come to find inputs, and then I'm going to click this little button here that drops my options down, and I want to set up a milliamp input. And just for the sake of ease, I want to configure this first one. So the very first thing I tell folks to do is to name everything you possibly can, and this includes your inputs. I will explain why. Number 1, we only have 4 inputs here, so obviously it's going to be easy to keep track of. But you can imagine that as we start adding inputs and outputs and channels, if things aren't labeled, it's going to get really, really tricky to set these up. And you'll see what I mean in further classes. So I'm going to name this input, let's just name it level sensor. You can name it whatever you want. It could be what it's reading. It could be the tank number that it's attached to, the serial number of the sensor, whatever it is that you want. So we name it, and then we have these filters. So these filters pretty much filter out the signal. It pretty much tells the it tells the input, it tells the Consolidator Plus when it's reading the inputs how long to wait before it actually reports a change in the signal. So the default is 8 seconds. And you know what? Now that I say that, I think I explained that incorrectly with the filtering. I don't think it waits 8 seconds for updates because that would be a little ridiculous. It might be an average of 8 seconds. It might be an average of the rolling 8 seconds. Well, either way, it's a filter. I can get more information on that later. So we have that filter, and then we have a bypass filter. And so what that means is that allows you to ignore a filter. So like, for example, let's say you have a filter on so that you are going to ignore small fluctuations in your signal. Well, within that filter, you might actually have a fluctuation of your signal that's, reflective of what's happening in your process. It's not just signal noise. And so this bypass filter allows you to say, for example, let's say I made this 10. If I made that 10, what I'm telling the consolidator is if the change in signal is equal to or greater than 10% of my full scale, consider that not a glitch or noise, consider that an actual reading. So that's what that bypass filter does. Then we have the glitch filter. It's just another filter you can put on there for noisy signals. We have break below. So what this allows you to do is this will tell the consolidator when a signal is considered broken or bad. So the default here is 0.01 milliamps. That's really small. So for example, let's say I change this to 3. What that means is that 3 milliamps, if my input goes down to 3 milliamps, rather than displaying the number that would correlate to 3 milliamps within my scale, it's just going to say, hey, it's broken. That's it. We're done. It's broken. And it's going to report a fault to the system, at which point we can actually create alarms based on signal breaks. We're not going to go over that today. That's actually something I did in the last class, that we're going to do. So there's that. Then we have a disable input channel. Now, you might be thinking, why would you want to disable an input channel? Well, the answer is pretty simple. So each input has an isolated 24-volt DC power supply. So let's say you buy one of these with 4 inputs, but you only need to use 1 or 2 of them at first. The other 2 are going to be used once you add onto your system. Well, since there's power supplies on there, even though you're not using them, they're still going to be drawing power. So if you want to save power that the unit is using, you can disable your input channels. That's basically what it's used for. So you can still configure your channels and configure your inputs with it disabled, but this just makes it so that the power supply is not on. Okay, so that is how we set up an input for milliamps. I'm not going to go over all of the other input types in detail. We can quickly take a look at a pulse input. So a pulse input, again, we can name it. We tell it the type. So this would be the type of output from your flow meter. Low gate, high gate, and then if you have a low speed, like a turbine flow meter or something, like a small paddle wheel or a turbine flow meter, you can click that, and that just that increases the sensitivity of the input. So again, you with the software, you can go ahead and poke around with this and see how it's all set up. The inputs are rather straightforward. So now that I have my input set up, I want to do something with that. I want to create a channel. I want to do something. So we're going to find channels here on the left side. And I'm going to take 1 second and peek back at the chat box, make sure everyone can still see it. Okay, no one says anything so far, so we're good. So I come over to this channels, and now I want to create a new one. And again, the first thing I'm going to say is to name it. So what do we want to name this channel? Let's just do, we'll do tank 1. Just keep it nice and simple. So I name it, and then I choose my function. So the function is pretty much what you want this channel to do. Do you want to scale a 4 to 20 milliamp signal? Or do you want to do a math function? Or do you want to enter in a K factor for a pulse input? That type of thing. It tells the consolidator what this channel is meant to do, aside from just display. So for this example, we're going to keep it simple, and we're just going to scale a 4 to 20 signal like you would on any other product. So you will notice when you click on functions, on the left side here, we have all these different categories, okay? And within these categories, there are different options. So for example, if I come into the scale category, we have all these different options here: K factor, scale factor, multi-point, square root, round horizontal tank, so on and so forth. A lot of these are actually explained in the study guide, and you will find that the study guide definitely goes into more detail on the explanations, and that's simply just for sake of time. So if we just want to scale a 4 to 20 signal, just like you would on any other, like a panel meter, we want to choose scale, linear, 2-point. So that means we tell it 4 milliamps equals 0%, 20 milliamps equals 100% of our scale. Or we could do multi-point. If you're familiar with our legacy products like the ProView, you'll know that those are able to have 32 points of calibration. The ConsoliDator Plus will allow you to do up to 50. So just expanded there. Nonetheless, let's just go ahead and click on the scale linear 2-point. So the first thing we do when we open up this window is we have to choose our input. Now, when I say input with a channel, it does not necessarily mean a physical process input. So I'll show you what I mean. For what we want to do, I actually do want my level sensor to be the input to this channel. But just to show you what I mean, for example, let's go ahead and say I already set up a channel. Well, I can make another channel the input to a channel. Or if I had totals set up, I can make a total the input to this channel. And basically anything on this list, I can make the system clock an input to this channel if I wanted to. So I only say this because the word input is used a lot in the different objects that we create, and it does not necessarily mean it has to be a process input. So we actually do want to use a process input for this one. So I click on analog inputs, and there we go. I got my level sensor. Now, again, if I didn't name my input and I had 28 of these here, you'd imagine how confusing it would be to pick the correct input, right? And so that's why I keep on repeating myself and telling folks to name everything you possibly can. So there we go. Our level sensor is the input. We have a 2-point linear scale. And now we have units. So to do that, we just click on the box. And again, just like with the function and with the input, the left side of here is sort of your category, so to speak. So we have time, distance, volume, pressure, so on and so forth. So let's just do gallons just to keep it simple. So we're just going to do gallons, and then I can choose how many decimal places my number is going to have, my calculated value is going to have. So to increase it, you press the plus button, and we can have up to 15. Sorry, I'm using a laptop, so sometimes the mouse gets sticky. But that's a little ridiculous. So I'm just going to use just the 1 decimal place because that seems rather reasonable. So now what we have down here is the scaling. And so we're telling the machine when our input is 4 milliamps, we want our output to be 0 gallons, or we want our display to show 0 gallons. When our input is 20 milliamps, we want it to display 100 gallons. Well, let's say it's actually a 1,000-gallon tank. Well, I'm just going to go ahead and change that to 1,000. Now, the last part here is cutoff. So what this is a display function. So, for example, let's just say when in a real scenario in a tank, it's very possible at the bottom of your tank that you're going to get, a 3.7 milliamp signal. Well, in our scale, 3.7 milliamps is below 0, and so you're going to get some weird negative number on the screen. Usually, it doesn't mean anything, and it's not going to harm anything, but sometimes a lot of end users get a little uncomfortable when display is showing negative numbers or erratic numbers. So what we can do is we can actually put this here. So what this is saying is when we get to 0 gallons, it's 0. That's it. If our signal goes down to negative 3.7 milliamps, it doesn't matter. It's always going to show you 0. So it's just a way to make sure that the bottom of your scale never goes to a negative value. Now, the last 2 things we can do on a channel is we can change the color scheme. Now, this is where we change, the color of the bar graphs or the channel itself. So what we do is we just click on the color scheme. You'll notice that we only have a default color scheme. But you know what? I'm going to go ahead and make a new one for you guys. So this isn't actually in the lesson plan. I'm just doing this on the fly. How cool is that? So I'm going to name this one green. And I want my text to be black just because it looks nice on the screen. I want the background of my channel to be this green color. And I want my bar graph to be that same green. Now, this checkbox down here, this says show alarm condition using alarm color setting. What this means is, with this box checked, if we get into an alarm condition on this channel, it'll change from the normal green color to an alarm condition color. And so you'll remember that, throughout the this entire course, whenever an alarm occurred, you saw the bar graph would flash and turn red or things of that nature. And this box is how we accomplish that. So if I were to uncheck that box, when we get into an alarm mode on this channel, it can still, have a relay output. You can still consider it an alarm, but it won't change the color. But I like that feature, so I'm going to go ahead and leave it there. And I press select, so now that's my color scheme. The last part here is bar graph. So with it checked, this means that when the channel is put onto a screen, it'll show you the bar graph and the numerical value. If it's unchecked, there is no bar graph on the screen. It's only going to show you this numerical value down. You'll also notice that my 100% of the bar graph is still only reading 100, but the top of my scale is 1,000. So if you do want to use a bar graph on the screen, we have to make sure that we go ahead and make sure that that number matches the top of your scale here. And once we do that, we click Save. So just to recap, we set up a 420 milliamp input, took a look at some filters, and then we made this input into a channel. Well, now we're going to need to be able to do something with that channel, right? We're going to want to be able to display it. And so in order to display it, we actually need to create a screen. So we look on this left side here, and oh, there it is, screens. I don't have any set up, so none show up here. And I'm going to go ahead and click New. And again, the first thing you can do is name it. So let's see, what should I name it? I don't know. How about Devin is cool. There we go. Nothing like a good lie, the name of the screen. And so this is the screen setup, and we want to add things to this screen, right? We want to be able to display something on the screen. So what we do is we click Add, or you can click Insert. It actually does the same thing. And again, just like with everything else we've done so far, on the left-hand side, you have your categories, so to speak, and then you have your options within those categories. So I want to add my channel, my Tank 1 channel, to the screen. So now it would display that tank reading. But you know what? Just for the hell of it, let's add my analog input as well, my level sensor input. Now this is an important part. You have heard me say many times that the ConsoliDator Plus can show 8 objects per screen. And I tried explaining to you what objects meant, and here is exactly what I mean by that. So a tank is an object, and it's a scaled channel. My level sensor, my analog input level sensor, when I put that onto a screen, that is considered an object, even though it is not a channel. Hopefully that makes sense. Or let's just say, for example, system clock. My system clock is not a channel, but it is an object that I can put on the screen. So that's what I mean by 8 objects per screen, and hopefully that's much more clear now. So we also have these checkboxes over here, and what these checkboxes are doing is allowing us to customize how the screen presents information or what it looks like. So, that first checkbox there is show title. I think it's clever to have names on everything, so I always leave that one checked. That one's good to go. The second one here, show channel number. I'm not a fan of it. I personally think it looks much nicer when you have a bunch of channels on the screen with no channel numbers. Just a personal preference. I just think it looks nicer, so I always uncheck that. The next two are sort of related. If you remember from a few minutes ago, we had a checkbox on the channel where we could tell it whether we wanted to display a bar graph or not, right? Well, we can do the same thing on the screen. So check this out. I can have, if with this box checked, the screen will show bar graphs as long as the channel itself is programmed to show a bar graph. So the bar graph checkbox has to be checked on the channel and on the screen for the screen to show bar graphs. If I were to uncheck this, it will never show bar graphs, even if the channel itself has the bar graph enabled. So this is just a good way to go ahead and override some of those bar graph settings so you don't have to go back and do it individually on the channel. Or let's say we have the bar graphs, we want to see the bar graphs, but we don't care about numerical values. We don't care about numbers. We only want to see those bar graphs, man. So we can just click on this box here, and now it's only going to show us bar graphs. I'm not a huge fan of that, so I usually leave that one unchecked. The last two checkboxes are sort of important. So when you have multiple screens configured on the consolidator, you can scan through them. We can have multiple screens, and the Consolidator Plus can automatically scan through each one of them, or you can stop that scan and use the arrows on the soft keys to navigate the screens yourself. Okay, so we also have dwell time, and this is customizable for each screen. So let's say you have 4 screens. One of them is really, really, really important. The other 3 are, they're nice to have. Well, you could make the one really, really important screen have a very long dwell time, and the other 2 screens or other 3 screens have a really short one. So the consolidator really focuses on the important screen and sort of skins past the other ones because we don't really care about those as much. So that's what that dwell time is. Again, customizable for each screen. Now, here's a really cool feature. Auto scan, check or uncheck. So what this means is the Consolidator Plus is going to want to automatically scan through screens. Let's say I have those same 4 screens set up, but there's one of them that's diagnostic information about sensors and things of that nature. You know, I don't really, it's not really needed for the operators to see it, but it would be nice for them to access it. What we can do is leave a screen unchecked from the auto scan. And what that will do is the Consolidator Plus will auto scan through all the other screens except for this one. But this screen can still be accessed if you manually get there with the soft keys. So if that's confusing, don't worry about that. All that's really important to know is that we can scan automatically through the screens and that each screen can have a custom dwell time. As far as leaving it out of the auto scan, you don't have to worry about that. I can explain that later. So that's how you set up a screen. You will notice that we have these F1 through F4 things on the bottom here that we haven't gotten to yet. Now those are the soft keys that I've talked so much about, and we're actually going to learn how to program those later. So I'm not going to go through that, but just know that this is where we program those soft keys. Now I'm going to save my screen, and that's it. So to recap, we set up our 4 to 20 millionth input. We turned that input into a channel. We created a screen. We added a channel and a couple other objects to it. Now let's set up an output. And let's say we want to set up a relay output, a high alarm relay output. Well, the first thing I do is I go over here and find, let's click these to make it nice and clean. First thing I do is go over here and look for output, and there it is. And then I look for, there's the relay output. Yeah, let's say I want just relay number 1. And again, we can name our relays. So we'll just say tank 1 high. That's the name of this relay, tank 1 high. The input, see, there's that word input again. The default is always off, meaning that no matter what, these relays will always be off. Or you can select a different input. So again, just like with everything else, the left side are your categories, right side are your options, and you can see that there's all sorts of different things that we can make the input to a relay. But for this, we want it to be a channel. We want it to be that tank 1 channel, so we do that. And we are scaled from, 0 to 1,000. So let's say I want my relay to turn on, or I should really say change states, let's say at 800 gallons. And we want the relay to return to its normal state at 500 gallons. That's all I do. So again, set and reset, or on and off, just means the set point is at which point in your scale do you want the relay to change states, and then at which point in the scale do you want the relay to go back to its normal state. This is a high alarm because my set point is larger than my reset point. If I flipped those and my set point was 500 and my reset was 800, this would automatically be a low-level alarm. And then we have on delay and off delay. All of those two are is this says, hey, when I get to 800 gallons, before the relay changes states, wait 10 seconds. Off delay, same thing. This says, okay, after we're clearing our alarm condition and now we're back down to 500 gallons, but I want the relay to wait 10 seconds before it actually changes states. Lastly, we have break. What this means is the break of the channel, okay? So if the channel itself were to break or the inputs to the channel were to break, we can control this relay to either stay as it is, force it on, or force it off. I'm just going to go ahead and leave it as stay as is, and we actually do some really cool control stuff with this later on in a future class. We also have this fail-safe button. So what fail-safe does, if you were to read our manuals, it says something about power loss and protecting equipment. But really what it is it inverts the behavior of the relay, or it inverts the function of the relay. For example, if I have a Form C relay and I have it wired normally open, that means under normal operating conditions, the switch is open, and in an alarm condition, it's going to close, and which completes the circuit. However, if I have a Form C normally open relay wired up, and I have my fail-safe on, what it's going to do is it is going to close so that the relay's normal state, quote unquote, is closed and its alarm state, quote unquote, is open. So it just inverts the function of the relay. And then we have pulse output. So I'm going to be totally honest with you folks. I'm not entirely sure why you would need to use a mechanical relay for a pulse output. If you know of an application or a reason, please let me know. But just so you know, it makes a square wave. That's what it is. So you tell it how long to stay on. 10 seconds, 5 seconds. So if I were to do that, the relay would turn on for 10 seconds, turn off for 5 seconds. Turn on for 10 seconds, turn off for 5 seconds. And it will just keep on doing that. Okay, so we have our relay set up, and it is tied to our input, or to our channel. Sorry. You guys ready for the big reveal? You want to take a look at what we've done? I'm going to go ahead and write this to my consolidator. So after you're done with everything, you always want to write, and that is done right up here. So, all right, cool. It loaded. Oh, you know what? Give me 1 second. I just changed the display settings because for some reason the camera, when the consolidator isn't all the way dark, it just doesn't look great on camera. So, okay, good. Got that. Now I open up my camera app. So now you should all be able to see my consolidator plot. So the name of my screen is Devin is Cool. Remember, it was the lie, the cool lie that we told. We have our level sensor value. We have our time clock. We have our real time clock. So you can see what time it is. And time is a little off. So that's probably my fault. And obviously we have to, we have the bar graph. With that, that is 4:30. That is all I have for you. I will stick around for questions if you folks have sent in questions already. So somebody asked me how to set up custom units. I'll tell you what. We weren't supposed to go over that today because that's going to be a topic in the future. But you know what? Why not? If you have a couple seconds, let's just go ahead and take a look. What I did is I went to the left side here. I found my custom units. I pressed new. I entered in my name. So, let's just do, I'll do miles. Okay, so I do miles. The type, a mile is a distance measurement, right? And for my base, let's say I want to do feet. Well, see, look at that. There's already miles there. But let's just pretend that it's not, okay? I would put feet here, because that's my base. And then I would put my factor here. Now, I forget what the exact number is, but let's just pretend it's 5,237 feet per mile. So if I were to do this, now I am able to actually convert. So if for example, let's say I was measuring something in feet, and I wanted to know what the equivalent was in miles, all I would have to do is create a new channel with the unit miles, and it's going to do the conversion for me. And so what I was showing you before is now if I go into my channel that I set up, and I go to units, I can go to distance and check it out. There's the miles. That's the one I created, and I know because I capitalized it. And so again, what I was trying to say is if we didn't put in the type or the conversion factor in base, your custom units will show up in custom. However, if you actually fill it out the way I showed you, it will show up in the library. And someone just corrected me, 5,280. Hey, you know what? I was pretty close for guessing off the top of my head. Okay, so I think everyone was able to see the custom units. Did anyone else have any questions or anything? And if not, that's totally fine. Just as a reminder, I did have that challenge for everyone, and it's completely voluntary. It's not mandatory. You don't have to do it. But if you weren't here on Monday or you didn't hear me, I have a challenge for everyone that if you can bring me an application, a reasonable application that you would typically reserve for a PLC, and I cannot make the ConsoliDator Plus do it, I will give you a free milliamp signal generator, a PD9502. So again, if you can stump the consolidator, if I cannot program the device to do what you would need to do, you win a $100 product for free. And just so you all know, next week we are going to be, or Monday I should say, it's only a couple days away. It's going to be week 8, and we're going to go over intermediate configuration skills. So it's going to be just an extension of what we learned today. We're just going to take what we learned today and expand on that a little bit, and it'll all come together really nicely. Last thing to say, the study guides on these classes, specifically with these programming classes, are going to be extremely valuable, extremely helpful. Before, you could definitely get through and understand everything we went through without the study guides. They were sort of a nice to have, but I promise you, for programming and understanding how to communicate with this machine, the study guides are going to be invaluable because I really went above and beyond and tried to explain things in terms that are just easy for anyone to just read through and understand. I wanted to make programming this as easy as possible for everybody. And so with that, that's all I have for you. I appreciate you guys taking extra time to come and do this redo course with me or redo session. If anybody has any questions, comments, concerns, any feedback at all, please let me know, especially about this session in particular. This is going to sort of be the new format moving forward. I will do my best to make sure that you can constantly see my screen share. But if you have any feedback at all, negative or positive, please let me know. If you don't like the format, if you wish I didn't share my screen, if you liked the slideshow more, let me know. Anything and everything. So I thank you. I hope you all have a great weekend, and I'll see you on Monday.